Good evening. I'm an educator from Kepler Educations, and this is the fifth video of the POTD series that we are currently doing. Before starting the video, I would request to everyone who is watching this video to help us achieve our target that was set in the previous video of 150 likes, more than 100 subscriptions, and a lot of views. I mean, I would expect something in the range of above 250 as a start. So this is a humble request from the side of Kepler Educations. Also, there is something that needs to be said, and that is we will soon be starting our venture of Kepler Educations as the website that I had displayed in the previous video. You would be able to go and buy your courses, and those who are interested in learning these courses, please put forward your request in our comments. Also, you can put forward your requests in the community group that we have. And one more thing, important thing is that whenever you come to our website to access the features like getting the community group, WhatsApp group, I mean not a WhatsApp group, the group that is created in Kepler, or to access the library, or to access the daily problems that we set. We will soon be setting contests. So to access all these features, you have to log in. Without logging into our website, it is not possible to access the features of Kepler 22 website. In this position, you would be able to select your courses. The courses has not yet started. They will be starting very soon, perhaps as much as we are targeting around September, October, we will be able to start our courses. Updates will be provided in this YouTube channel. Any updates will be provided in this YouTube channel. And when you make a payment, you shall be able to see, the library resources, the group chat, as well as the meeting where you shall be having live classes. So if anyone is wishing to join for studying and to hone your skills to get a good job in the market, in today's market, of filled with recession, this is a very good place for you to start your journey. But anyway, so before wasting time, I mean, I am wasting a lot of time. So without wasting any more time, let us dive deep into our problem. So the problem today is minimum days to make M bouquets. So we have a row of flowers where each flower blooms after a specific day. The array ARR represents the blooming schedule. Error of I is the day the flower at position I blooms. To create a bouquet, you would need k adjacent bloomed flowers, and each flower can be used only once in one bouquet. So we have to find the minimum number of days required to make exactly m bouquets, and if it is not possible, then you have to return -1. You do not have to think much about this -1 throughout the algorithm, because the algorithm is such that it will automatically take care of this -1 thing. Minimum days to make m bouquets. Sorry. Make m bouquets. BOUQUETS. Perfect. So you will be given an array. Let the array is 3, 4, 2, 7, 13, 8, 5. 3, 4, 2, 7, 13, 8, 5. From this array, you see the flower I, or 0, 1, 2, 3, 4, 5, 6. The flower 2 blooms on the second day, and today is the 0th day. So you have to find out the minimum number of days that is required to make m bouquets. K is the number of flowers in one bouquet, and m is the number of bouquets. BOUQETS. So you see, if today is, let's say, the 10th day, so this can, and k, the value of k is given as 2, the value of m is given as, let's check, 3. So this can be one bouquet, this can be second bouquet. Okay, so let us go step by step. 3, it has already bloomed. 4, it has already bloomed. 2 adjacent flowers bloomed, take them in a bouquet. 2, already bloomed. 7, already bloomed. 2 adjacent flowers bloomed, take them in a bouquet. 13, not bloomed. Because this flower blooms on the 13th day, and today is the 10th day. So it will bloom after 2 more days. This has already bloomed, this is already bloomed. two flowers, adjacent flowers bloomed, take them. Therefore, what becomes is that, so you have three bouquets, one, two, three. Therefore, there are three bouquets. That's three bouquets, and one, two, three. So there are three bouquets, and okay. So for the 10th day, you can make three bouquets, but you have to find a minimum number of days when you can make three bouquets. Let's say you take 8. You will see that at 8 also, you will be able to make three bouquets. At the 8th day also, you will be able to make three bouquets out. This is the first bouquet. This is the second bouquet. This has not bloomed yet, but this has bloomed. So this is the 8 and flower blooms. In the morning, the flower has already bloomed. So this has bloomed. So there are one, two, three bouquets. But on the 7th day, is it possible? Let us. So on the 7th day, this has bloomed. Okay, this has bloomed. Okay, so let us consider it to be 6th day. 6th day. 7th day, it is actually possible. On the 6th day, so this has not bloomed. So you cannot take this one. You cannot take this one. You cannot take this one because 7th. This is the 6th day. This is the 6th day. This will be bloomed tomorrow. This will bloom after long many days, and this will bloom the day after tomorrow. But this has already bloomed. See, this is 3. This is it goes after 8, 5 here. This is 6th day, and it is already bloomed. Therefore, this has bloomed. This has bloomed. These two flowers are adjacent to each other. See, these two flowers are adjacent to each other in terms of blooming. There are flowers in between them, but these have not bloomed, so they will not be considered. If you create an array, 3, 4 of those bloomed flowers, 2, 5. If you create an array of bloomed flowers, you see that 2 and 5 are adjacent to each other. So you can take. So the condition is you have to take adjacent bloomed flowers. If the bloomed array is 2, 3, 5, 6, then you cannot take 2 and 3 in a bouquet. You have to take 5 and 6 in a bouquet, 2 and 3 in a bouquet. This is not possible. You cannot take them in a bouquet. You have to take 3 and 5 and 6. But we will not be needing a bouquet. This is just I showed you to make you understand. So on this day, you can make effectively 2 bouquets. So for on the 6th day, you can make 2 bouquets. But on the 7th day, you see that you can make 3 bouquets. 1, 2, 3. So your answer will be 7. Your answer will be, sorry, 3, 4, 2, 7, 13, 8, 5. 3, 4 bloomed. Okay, so it is 8. Yeah, on the 7th day. Okay, let's see. Let's check on the 7th day. We haven't really checked on the 7th day yet. We haven't really checked on the 7th day yet. Sorry. We haven't really checked on the 7th day yet. So it is proven that on 6th day it is not possible. Let us do 6, 7, and 8 once again. 3, 4, 2, 7, 13, 5. 3, 4, 2, 7, 13, 8, 5. On the 6th day. On the 6th day, what do you do is this 2 is bloomed and not bloomed, not bloomed, not bloomed. These 2 is bloomed. 2 bouquets are not possible. On the 7th day, what do you do? On the 7th day, what happens? This 2 is definitely bloomed. These 2 is bloomed. Not bloomed, not bloomed. Okay, 5 is bloomed. But you need 2 flowers. Since k equals 2, you need 2 flowers to make a bouquet. So you can make 1 bouquet, you can make 2 bouquet. However, there is nothing in here, nothing is here. So you cannot take this into a bouquet. Even though this flower is bloomed, you cannot, even though this particular flower is bloomed, there is not a second bloomed flower. There is not a second bloomed flower. So you cannot take another bouquet. So you have only 2 bouquets. But you need 3 bouquets. So 7 cannot be the answer. 7 cannot be the answer. So let us try for 8. If we take 8, we see that on the 8th day, these 2 is bloomed, these 2 is bloomed, it is not bloomed, but these 2 is bloomed. So there are 2 flowers in here, 2 flowers in here, 2 flowers in here, that is being a bouquet. So it is a valid bouquet. On the 7th day, this 8 has not yet bloomed. 5 had bloomed, but there is nothing afterward. So you have only 1 flower. You do not have 2 flowers to make the bouquet. But on the 8th day, you have 2 flowers to make the bouquet because this 8 is bloomed and 5 and 5 and 8 are adjacent. So you have 3 bouquets total. So 3 bouquets. Now on the if you on the day 7, if on the day 8, if you can make 3 bouquets, then on day 9 definitely you can make 3 bouquets because all these flowers is already bloomed on the 8th day. On day 9, these 3 flowers was already bloomed on 8 days, so you can definitely make 3 bouquets. So above 8, always you can make 3 bouquets. So the minimum number of days required to make 3 bouquets is 8. So you will return 8. Why 7 is not possible? Because I will just repeat this particular answer, this particular thing once again. 7 is not possible because on the case of 7, there was 8 and there was 5. 8 was not bloomed on the 7th day and 5 was bloomed on the 7th day, but there is nothing after 5 that will pair up with 5 and create a bouquet. So creating the third bouquet is not possible with a single flower. However, on the 8th day, this particular 8 is already bloomed. So there are two flowers that are available to create a bouquet. So there are 3 bouquets and 3 bouquets are needed. So you will return 8. Very well. So there are things that you have to observe from here. The things that are already that I have already mentioned, and you need to observe is that okay. The if a flower if m bouquets if m bouquets are possible on ith day, then definitely those m bouquets are positively those m bouquets I mean those are positively possible on any day y any day j where J is greater than I. Because on the ith day, these two flowers have already been bloomed. Then obviously on the I plus 1th day, they're already bloomed. I plus 2th day, they're already bloomed. On the I plus 3 day, it may be possible that there is another bouquet that is bloomed, but that is not necessary, right? Because we need only the 3 bouquets. So on any day more than I, if it is possible on I, then it's definitely possible more than I. However, if on the day I, if on the day I, if on day I, if m bouquets are not possible, if m bouquets are not possible, then on any day j where j is less than I, m bouquets are not possible. Why? Because if let's say these two are created on ith day, these two are created on ith day, but this has not been created on the ith day. Then on the I minus 1th day, maybe it happens that these two are created, but obviously this flower, which will bloom on let's say I plus 3th day, is not going to bloom on I minus 1th day. So creating the bouquet is not possible. Similarly, on the I minus 2th day, this bouquet might not exist. So if on ith day, if on ith day the formed, number of bouquets formed is, there can be two things. One is that it is less than equal to x, but okay, this comes, all right, let's do it. If the number of bouquets formed, if the number of bouquets formed on the ith day is greater than equal to m, did you understand on I plus 1th day, it will always be greater than equal to m. I plus 2 will always be greater than equal to m. But you have to find the minimum day when m bouquets are possible. So obviously this can be an answer. Obviously I can be an answer. Because on the ith day you are making m bouquets. But on you have to find out a minimum number of minimum day, the lowest day when m bouquets are possible. So you have to decrease the value of I. So you have to decrease the value of I. How can you decrease I? I'm coming to that. And if you can do a linear search, you can do a binary search. Why binary search? If number of bouquets formed is less than m, on any day I minus 1, I minus 2, I minus 3, you cannot form m bouquets. It will always be less than m. So you have to increase I. So you have to increase I. Increase I. These are the two conditions. Now, if you have to make a bouquet, if you have to make a bouquet, all right. So what will be the first day that you will start from? So it is a 0th day, and let's say the first flower blooms at this day, and the last flower blooms at this day. If the first flower blooms at this day, means this flower will bloom a day after this. So B is greater than A. This flower will bloom after this. So D is greater than A. Effectively, if you see, this A is the minimum value in the array. And let's say X. This is Y. This is, okay, I don't need Y. So this is the last flower that blooms. This is the last flower that blooms. So this means D must be less than X and B must be less than X. Effectively, this X is the maximum value. On this day, the blooming start. On this day, all the flowers are bloomed. If all the flowers are bloomed, then if definitely you can take three bouquets. And if no flower is bloomed, you cannot take any bouquets. So you understand that the day, the search space of the day will always lie between A to X within this place. Within this place, the search in this range, answer lies. One more observation. These are days. From A smallest day keep increasing day to reach x. Therefore, a to x is increasing. Therefore, it is sorted. If it is sorted, you can apply binary search. If it is sorted, you can apply binary search. Now, how to this problem is actually so simple that you do not. I will not explain the linear search again. It is very easy to understand. The linear search is very easy. First, all right, let's just write a linear search. Okay. First, let us write a linear search for int I equals low. Okay. So you understand what is low? Int low equals minimum min val of ARR and int high equal max val of ARR. You do understand this will take open time. The two of them will take open time. But I equals low, I less equals high, high plus plus. But the first few days creating M bouquet is not possible. Let us say CNT is the number of bouquets that can be formed on day I. How to find it? Let's say I have a function find count, which gives me the number of bouquets that I can form on ith day. If CNT is less than x, do nothing, just keep on integer. But if CNT is greater than equal to x, the first day when it is greater than equal to x, you will say answer equals I break. The first day or the minimum day is found out when you can make x bouquet, sorry, m bouquet, m bouquet, and you will return answer. Converting these into binary search is very easy. I will just write a code here. While low is greater than equal to less than equal to high. You see the constraints here are very small, 10 to the 5 order. So you can easily do int mid equals low plus I by 2. You do not have to do low minus low plus I minus low by 2. Low plus I minus 2, low by 2. You do not have to do it. Until count, until midday, let's say the number of bouquets is find count mid comma, sorry, error comma mid. Alright, let me just go before first. You see, I told you here decrease I and increase I. If the number of bouquets formed is greater than equal to m, then decrease I. Why to decrease it? Because if on ith day you can form something more than m bouquets, then obviously it is an answer, and you have to find a minimum days. So above I, it will always be able to form those greater than equal to m numbers, m bouquets. But less than I, you have to see which is the minimum day when you can form greater than equal to m bouquets. So how to decrease in binary search? High equals mid minus 1. Nothing more to explain. Similarly, increase I. How to increase it? Low equals mid plus 1. On the fourth day, you are not able to form m bouquets. So on the sixth day, you can be able to form m bouquets. So increase the mid. Low equals mid plus 1. So as simple as that. Find count error comment. If CNT, one second. Yes. If CNT is, let's say, greater equal to M, as simple as that. If you can form on this immediate day, you're able to form more than M because on n plus 1 day, you will be able to form more plus 1 bouquets. So this can be an answer since you are able to form M bouquets. And you have to find a minimum value of the day. So you have to reduce mid, I equals mid minus 1. Let you keep a condition in ANS equals minus 1. And else, on the immediate day, you're not able to form M bouquets, so you have to go higher. So low equals mid plus 1. So this concludes our binary search and you will return answer. So before going to time and space complexity, there is this find count answer thing that we have to do. Now look, you have to find out the I on the ith day, how many bouquets are there? Number of bouquets on ith day. How to find the number of bouquets on ith day? How to find the number of bouquets on ith day? You start from the first of the array. You see whether this has bloomed or not. If it has bloomed, keep a counter, 1, and keep another counter. Let's say I do it, I've given it a name, what the name I given it, sub counter. Let us say keep this sub count as, okay, count should be initialized with 0 equals 0. So when you come here, you see this has already bloomed or not. If it has already bloomed, you increment the sub count. You increment the sub count. If this has already bloomed, you increment the sub count. You see that if the value of sub count equal to k, if the value of sub count equal to k, then you can make this a bouquet. So this count counts the number of bouquet. So you will increase count to 1. And since a bouquet has already been taken, and now you will start afresh, you will make the value of sub count 0. So here you see this is not yet bloomed. This is not yet bloomed. This, however, has bloomed. So you will make sub count 1. This not yet bloomed. This not yet bloomed. But this has bloomed. Let us say you make it 2. I am assuming hypothetical numbers. I am assuming hypothetical numbers. So this sub count is 2. This is bloomed. Let me just make it. The green ones are bloomed. The green ones are bloomed. This is bloomed. This is bloomed. This is not bloomed. This is bloomed. These two are not bloomed. This is bloomed. So sub count equal to 2. You see sub count equal to k. Therefore, you can increase this particular value to 2. You can make this 0 and you can make this a bouquet. So what is the number has been found? Return 2. Number of bouquets. The number of bouquets on the item is 2. This is how you will find a find count. Let us write a find count function. In find count vector int ampersand arr int, let's say day, int k, the number of bouquets needed, number of flowers in a bouquet. Let's say you do int count equals 0, int sub count equals 0 for auto it belongs to arr. How to check if a flower is bloomed or not? If error of I, that is it, is less than equal to days, I have given a day, right? Yeah, day. Less than equal to current day, that is blooming day was before the current day, that is, it means it has bloomed. Its blooming day, that is it, is less than the current day. It blooms on 4th day and today is 6th day. So it is already bloomed. Therefore, sub count plus plus. If SC equal to K, as I said, CNT plus plus, SC equals 0. This is the condition. And at the end, you will write return CNT. This was the sub count. So before going to time and space complexities, let us first show you the code. So this is the way you will find out the minimum value of the array and the maximum value of the array. This is the minimum value of the array, which is the first day a flower will bloom. So before this day, before this lowest day, you cannot hope to get a single flower bloomed. Forget about bouquets. You cannot hope to get a single flower. So this low is the first day when a flower blooms, and this high is the day when the last flower blooms. And this day you will get only flowers, so you can make as many bouquets as you want. So is the lowest value of the array, it is the highest value of the array, it is the search space. In n is equal minus 1, in case m bouquets are never possible. M bouquets are never possible, that is, if count n equal to m, this particular condition does never happens. The number of bouquets till the high value always remains less than m. That is why I said if it is not possible to make m bouquet into minus 1, you don't have to think about this at all. If this counted, if for all the day till high, the number of bouquets that can be found is less than n, then automatically this ns will be minus 1 returned. So anyway, where low is n equal to high, you'll find out the mid. You'll find a number of bouquets on the mid day. If the number of bouquets on the mid day is greater than equal to m, on the mid plus 1 day, it will always be greater than equal to m. And you can find m bouquets, so it can be an answer. As well as you have to find out the minimum day on which m bouquets can be found. So you have to reduce the search space. So high equals mid minus 1. If on the mid day you cannot find m bouquets, you have to go above, you have to go on the following days. So you have to increase the mid. So low equals mid plus 1. Now let's find a find count. Let's see the find count. To find count, just a function that I've written. You will first initialize a count. This will count the number of bouquets. This sub count, it will count number of flowers in a bouquet. So if it less than equal to days, this means whether the flower has already bloomed or not. This means the flower has the flower already bloomed. IT is let's say 4, days is let's say 6, current day is 6, and 4th day the flower is bloomed. So the flower is bloomed today. So sub count equal to sub count plus 1. If sub count equal to k, that means k adjacent flowers has been found. K adjacent flowers has been found. You can make it a bouquet. Count equals count plus 1. Increase the number of bouquets and make the sub count as 0. Since a bouquet has been found, So from here you will start from 0. Not here exactly. From here you will start from 0. A bouquet has been found. Take them. So you will set the sub count as 0. Again 1, 2 equal to k. Increase the counter, increase the number of bouquets, make it 0. 1, 2, make it 0. So on. And you will finally return count. This is the overall algorithm. Let me run and submit it before going to the time and space complexity of this particular solution. As you can see, it is perfectly submitted. Now let us go to time and space complexity. Yes. So this particular part, as you can see, it is taking O of n time. Why? Because of this for loop. Which goes O of n times. Now, what is the range of high and what is the range of low? Okay, this is particular time thing is taking O of n time. And now let us see at a binary search. So the low at max can be 1, and the high at max can be 10 to the power 9. Low can be 10 to the power 1, high can be 10 to the power 9. So since 1 is a very small number compared to 10 to the power 9, let us the search space is, and we step by step 10 to the power 9 minus 1, which is 10 O of 10 to the power 9, which is O of 9 log 10. Okay, O of 9 log 10. So the overall time complexity becomes O of n plus O of n into 9 log 10. The space complexity becomes O of 1. So this is the overall algorithm of today's problem of the day. As always, this entire notebook shall be provided in this particular website, our official website. In the community group of resources section of our library, you have to sign in to view the library in navbar. If you wish to study at Kepler Educations, then please put a comment in YouTube or tell us at the community group at group chat of our website. This one. Sorry. This one. Okay. This one. Alright, so this is the end of today's lecture. This notebook shall be provided within today. Please do register and sign up to our website because the number of sign-ins are still very small, and please help us in attaining our targets. So this is all for today. See you in